In this video, we will learn how to solve a higher order differential equation with some function of x. They are kind of trigonometric functions. And we know that the general solution for finding a differential solution for a differential equation is yc plus yp, where yp is particular solution and yc is a complete solution. We know this. We are given this question that is with the highest order 2 and trigonometric function of x. Let's solve it. So first of all, we have to form an auxiliary equation. This auxiliary equation will be converted into the form of differential operator and we have also equated to 0 because we are making it a zero solution. So first of all, write down the auxiliary equation. That's the part we have, the differential part, the left hand side, and use differential operator in order to represent the differential dy by dx. After forming our auxiliary equation in terms of differential operator, we will find the roots of the above equation, of this equation. Such as in this case, the roots are -1 and -1. These roots are repeated and real, so we will write it in this form: a constant plus coefficient into x multiplied by whole e to the power -1, that was a root, into x. This is our yc. As in our question, we were given the fx part, that was 2 sin x cos x. We would like to replace it by sin 2x because they are equal. Now we will find our particular solution. For particular solution, we know that the function of x will be divided by the function of differential operator. So for that, but there is one more thing we have to do beside this, because our function is trigonometric. So there is one rule that we could apply. That's not a rule, but that's a technique. And the technique is that we will substitute the d square term in our function of the differential operator. We will substitute d square term by minus a square. What's a? A is coming from this our question, or the fx term, and that will be inside that will be the angle, the multiple or the coefficient of x in the angle. So after substituting, this was our differential function of the differential operator. We will replace all d square terms by minus a square. Here a was 2. Since a was 2, we will make it -4, and we will substitute all differential operator squares by a square, minus a square. After this, we will get a term that will be either, it might be in terms of a complete constant value or in terms of differential operator also, that it could be in terms of differential operator. In this very case, we will, after coming here, we will multiply, we will introduce the conjugate of this term. The conjugate of this term will be multiplied by this whole yp. After this, here the identity applies, that's a minus b into a plus b, and since then we will again get our term into d square, because this will become 4d square. So after this, so now after replacing all our d square term by a square minus a square, we will get our denominator free of differential operator, and differential operator won't be left, and only one differential operator that was introduced because of our conjugate will get multiplied by our trigonometric term, or the fx term. After this, we will differentiate that term because d has been multiplied. Okay, d has been multiplied. Before this we were writing it dy by dx. Now we are writing it d sine 2x upon dx. So we will differentiate this term and proceed. This is sine 2x. So this will become cos 2x into 2. We will solve this whole question, this part, and this will lead us to the particular solution. As we said before, our general solution for this differential equation will be yc plus yp. So our yc was some constant plus some coefficient of x into x multiply whole by e minus x. Then we added the yp term, and this is what we are getting. Thank you.